The region R is the base of a solid. For this solid, the cross sections perpendicular to the x-axis are semicircles. Find the volume of the solid. So first step is to know the area of a semicircle. And area of a circle is pi r squared. Semicircle is just half of that, so 1/2 pi r squared. Boom. Second step is to integrate this function. So integral 1/2 pi r squared. We can move out all the constants. 1/2 pi integral. Because this is perpendicular to the x-axis, we're going to use the x coordinates where the graph intersects. So that's going to be -3 to 3 r squared. We don't know what r is. We do know that the distance from here to the top of the distance of this rectangle right here would be top minus bottom. And because this is a semicircle, we want half of this distance. So we want top, which is big R, minus bottom, little r. And then we want to divide that by 2 to get half the distance of it. So big R minus little r divided by 2. And our big R, again, is this graph, which is over here. This is our big R, and our line, this is our little r. So putting that in, big R is 20 over 1 plus x squared minus little r, which is 2. And we want to divide that by 2 to get half the distance, which is the radius, and square that. Now you could put this in a calculator, but it might get a little messy, so we can clean things up. This squared affects both the numerator and denominator, so then if I were to simplify this, I'm just trying to make things easier for us, so I'm going to take out that denominator. And again, it's 2, the 2 is being affected by the square, so it's 2 squared, which is 4. And then we can move out that 4. This is technically a 1/4 because it's in the denominator, so 1/4 times 1/2 pi, so give us 1/8 pi integral from -3 to 3, 20 over 1 plus x squared minus 2, all squared. Putting this in a calculator, you get approximately 174.268. And then on the AP test, you'll get a point for your answer and a point for either integral you set up. It could be this one, it could be that one, or it could be one back here. Okay, so another way to do this problem is just to know the formula of volume of a semicircle, which is right over here on the left. So we'll start off with pi over 8, the integral from a to b. Again, because this is perpendicular to the x-axis, we're going to use the x-coordinates of the intersection points. So this is going to be from -3 to 3. Y squared just represents the height of the rectangle. So if we were to draw a rectangle that goes through this graph, the height of it would be top minus bottom. So we would take the top graph, which is 20 over 1 plus x squared, minus the bottom one, which is that blue line, 2, and then square that. And then putting this in the calculator, we should get approximately 174.268. So this is, just knowing this formula, it makes our life a lot easier than what we had to do before.